We will study the convergence in Routh theorem today. Okay, what is convergence? By convergence, we mean when we see that the particular value, in case in our course for today, that is the time path, whether it is converging to a particular point or not. Okay, basically, when we talk about the particular point, we are concerned with the equilibrium point. Okay, so therefore, we will study the convergence through the Routh theorem. Okay, Routh. Now, this is a theorem which is studied for the convergence of the time path. Instead of studying the roots, we will study the we will use the determinants to find out the convergence or divergence of the variables. Okay. So the solution of high degree characteristic is not an easy task. So for this reason, what we do is that we find a way of ascertaining the convergence or divergence of the time path without having to solve the characteristic roots. What we will do, we will find out the convergence or divergence of the time path, okay, whether it is converging or diverging, clear, without solving the characteristic roots. Now, the method that exists to provide the qualitative analysis of differential equations is known as Routh theorem. So Routh theorem provides an easy approach for the determination of convergence. Again, जो मैंने आपको बताया, suppose this over here ये converge कर रहा है और ये यहाँ पे diverge कर रहा है. Routh theorem provides an easy approach for the determination of the convergence or the divergence of time path of higher order differential equations with the help of determinants, which are formed by the coefficients of the concerned differential equation. When we are given the differential equation, okay, suppose this is our differential equation y3t, okay, suppose we have a value 2 over here, plus 4y square t. Now, plus let this be 2y t, 2y prime t. Now this is an equation, okay, let it be equal to 4. Now this is an equation. The highest order derivative of this equation is 3. That is, the function is derived 3 times. Therefore, y cube t over here shows the highest order derivative of this equation. This 2 is the coefficient of the third order derivative that was taken. Okay. Now 4 is also the coefficient. Okay, for the second order derivative of the function taken, and then again this 2 is the coefficient of the first order derivative. So these 2, 4 and 2, these terms will be used to find out whether the time path is converging or diverging. Therefore, हमारे पास क्या है? What we have is that we have different coefficients with in the higher order differential equation, and these coefficients will be used to find out whether the function is converging or diverging. And these coefficients will be used through determinants. That is, the determinants of different values will be determinants of the function will be formed, and they will be studied to find out whether the function is converging or diverging. Now, what will we do? What will be our first step? The first step will be, if we want to study the 1 cross 1 determinant or find out the value of the 1 cross 1 determinant, of course, this will be taken from a square matrix of 1 row and 1 column. Now, this A1 will be the value of the 1 cross 1 dimension of a matrix whose determinant was taken. Because we very well know that the determinants they are taken from the square matrices only. Then we have a 2 cross 2 matrix. Okay, here we will have A1, A3, okay, and A0 and A2. This is how you should find out the determinants. Now, what is the same over here? Let me now elaborate it to you. The highest order derivative is y3t. Okay, the coefficient associated with this higher order derivative will be referred to as A0. Okay, the coefficient associated with the highest order derivative is A0. So therefore, when we see this A0 over here in this determinant, we know that we are talking about the value 2 from this particular equation. Okay, from this particular equation, if you want to find out the determinant of a 2 cross 2 matrix, then the A naught that is given, it means that we are talking about the value 2, which is associated with y cube t. Okay. Then we have over here A1. Now the second coefficient, or the coefficient with the second highest order derivative. Okay, we don't know. It can be second order derivative or it can be 10th order derivative as well. Okay, we have n polynomial equation. Most of the time we have n degree polynomial equation. So therefore, A1 will be the coefficient associated with the second highest order derivative. Over here, the second highest order derivative is y 2. Okay, so therefore, this A1 will be 4. So wherever we see A1, we will associate it to be equal to be 4. Okay. So therefore, the value of A1 over here is 4. Again, the value of A1 over here is equal to 4. So therefore, we will write 4 over here. Now, what is A3 over here? Now, over here we have the third highest order derivative is y prime t, and the coefficient associated with it is equal to 2, and this 2 will be equal to A2. Wherever we see A2 for this particular equation, we will substitute the value of 2. Okay, we are talking about this 2 over here and this 2 over here. Okay, now what happens next is we have A3 also in this determinant, but in our equation we do not have A3 because after this we do not know what is the value of what is the coefficient associated with the simple function, that is y t ke saath we do not have this particular value, so therefore it will be put equal to 0. So our 2 cross 2 matrix will be 4, 0, 2. The value of A0 is 2 and the value of A1 is 3. Okay, the value of A1 is equal to 3 over here. It is not equal to 2. There is one small error committed over here. No, sorry, it's correct. It's correct. No, there's no error committed over here. This is not A1. Rather, this is A2. I'll have to rewrite it again. Okay. No, there's no error committed over here. It was actually A2. I thought I have written A1 over here. So therefore, what happens over here is that we should have the value 2 over here. So therefore, our 2 cross 2 matrix is 4, 0 and 2, 2. When we solve it, we get a particular value for it. Suppose it is 4 2s are 8. We know that we do cross multiplication for the values in the determinant, and therefore substitute the second value from the first value. 4 multiplied by 2 is 8, 0 multiplied by 2 is 0. Therefore, 8 minus 0 is equal to 8. Okay. Now, what happens next is that we have to determine that after checking out these determinant values, whether our time path is converging or diverging towards a particular point. Okay. Now, when we have, I'll simply elaborate and discuss it over here. When all the determinants are positive, okay, when the first determinant, the value of the first determinant, that is 1 cross 1 matrix, the value of 2 cross 2 matrix, the value of 3 cross 3 matrix, the value of 4 cross 4 matrix, when they are all positive, then what we say that all the determinants are positive. Therefore, the time path is convergent. Okay. When all the determinants are positive, then the time path is convergent. Therefore, in order for the time path to converge, regardless of what the initial condition happens to be, all the characteristic roots of differential equation must have real parts which should be negative as well. Therefore, the Routh theorem can be of direct help in testing the convergence. Well, now this particular topic will be explained further through a numerical where we have a question of this form, that is y4t That is the highest order derivative over here is the fourth derivative of the function plus y cube t. Okay, the second highest order derivative is third derivative with y cube. Okay, let me just, then we have 6y cube t. Okay, then the next one with us over here is 14 y square t. Okay, then we have 16 y prime t. Okay, and then in the end we have the simple function. Okay, that was taken, and the coefficient with it is 8, and the function is y of t, and this whole equation is put equal to 24. The first step is to determine the values of coefficients with the different order derivatives. Simple function is this one. Then we took the first order derivative of it. Then we took the second derivative of it. Okay. Then we took the third order derivative of it. And then we took the fourth order derivative of this function. So now we have nothing written over here. Therefore, it means that the coefficient with the highest order derivative is equal to 1. And the coefficient with the highest order derivative is always equal to a naught. Therefore, the value of a naught is equal to 1. The coefficient with second highest order derivative is equal to 6. Therefore, a1 is equal to 6, and the coefficient with second highest order derivative is always put equal to a1. The coefficient with third highest order derivative is always put equal to a2, and the value of a2 over here is equal to 14. The coefficient with fourth highest order derivative is always equal to, coefficient with the, this is now equal to a4 is equal to 16. Okay, this is the highest order derivative, clear? Then the second highest order, third highest derivative, and then the fourth highest derivative is equal to a4, which is equal to 16. The coefficient of the main function is equal to 8. Therefore, it is equal to a5 over here with us. We can find out different determinants now given the values of these coefficients. We can find out the determinant 1 cross 1, 2 cross 2, 3 cross 3. And if we also try, we can find out the determinant for 4 cross 4 as well. So now let's start with 1 cross 1. For 1 cross 1 determinant, we always take the A1 determinant. Okay, that is the value of 6 is the determinant for A1, and it is equal to 0. Then we have, for 1 cross 1 determinant, we will always put the value of A1 in that determinant. Okay. Now for 2 cross 2 determinant, what we will do is that we will put the values of A. In the first row, we will have A1, A3. In the second row, we will have A0, A2. Okay. A0 and A2. So therefore, the value of A1 is equal to 6. Okay, the value of the value of A3 is equal to 16. Okay, yeah, I was like a bit. This is the value of A3. This is the value of A4. Yeah, when I was writing it, I was like a bit. I guessed that I committed. Okay. Now the value of A3 is equal to 16. The value of A4 is equal to 8. So therefore, A1 is equal to 6. A3 is equal to 16. A0 is equal to 1. A2 is equal to 14. How will we find the determinant? Cross multiplication, 6 multiplied by 14, 16 multiplied by 1. So therefore, 6 multiplied by 14 is equal to 84. 84. and minus 16 multiplied by 1 is equal to 16. 84 minus 16 is equal to 68, and the value of 68 is greater than 0. Then we will make a 3 cross 3 matrix, okay? Now what we have in 3 cross 3 matrix, the first two elements are A1, and then we will have A3, and then we have A5. Okay. In the second row, we will have A0, A2, A4, A0, okay, A2, and then we will have A4. Then the third row will have 0, A1, A3. Okay. What we will do next is substitute the values of all the coefficients in the determinant. We will have 6, 16, and 0. Then we will have 1, 14, and 8. Okay, 1, 14, and 8. And in the last row we will have 0, because 0 will be 0, of course, and A1 is 6, A2 is 16. A3 is 16, okay? Now solve the determinant for this. We know that we will solve it, over here we will solve it through first row operation. We will take 6 common first. Then what will happen is that we will have 14 multiplied by 16 minus 8 multiplied by 6. So 14 multiplied by 16 is 224 minus 8 multiplied by 6 is 48. Then we have 16, okay, and we will get 1 multiplied by 16 minus 8 multiplied by 0. 1 16 is 16 minus 8 multiplied by 0 is 0. Then the next will be 0 into 1 multiplied by 6 is 6, okay, minus 14 multiplied by 0 is 0. Okay, let me write it properly. 1 multiplied by 6 is 6, minus 14, 0 is 0. So therefore, through solving these mathematical values and these mathematical values, our determinant value is equal to 800. Again, which is also greater than 0. This is 3 cross 3 determinant. Then we had a 2 cross 2 determinant as well earlier, and its value was also equal to some positive number. Okay, now let's move to 4 cross 4 matrix. Okay, in the 4 cross 4 matrix, again, what will happen is that our values will be A1. Okay, let me write it up right. Now, we will have A1, then A3, then A5, and then A7. Okay. Now, the value of the coefficient for the odd coefficients will start increasing. Okay, the first row elements will be A1, A3, A5, A7. Second row elements are now 1. Okay, they are now A0. Okay, A2, A4, and A6. Third row elements will start now, they will start with 0, A1, okay, then A3, and then we will have A5. Okay, and then in the end we will have 0, A0, and A2, and then we will have A4. Substitute the values for these coefficients. What we will get over here is that 6, 16, 0, 0. Okay, 6, 16, 0, and 0. Then we have 1, 14, 8, and 0. Then we have 0, 6, 16, 0. Clear? And in the end, we will have 0, 1, 14, 8. 0, 1, 14, and 8. Now, how to solve the determinant for this particular matrix is we will have to subdivide it into smaller matrices. So we will get over here, the first one will be, again, we will solve it through the first row operation. We will have a 6 over here, then we will have a 3 cross 3 matrix. We will write 6, okay? Then a 3 cross 3 matrix, that is 14, 8, 0, 6, 16, 0, and 1, 14, 8. 14, 8, 0. Then we have 6, okay, 16, and 0. And then in the end, we will have 1, 14, and 8. Again, just like we did previously, we will assign a negative sign over here, and then we will write 16 over here. Okay. So therefore, by taking this 16, it means that we are taking the element of first row, second column. These values will be, now these values will be eliminated. So what will be left over here is 1, 8, 0. When there are many zeros in a determinant, then again it becomes easier to solve it because the multiplications are reduced there. 0, 16, 0. Then we have 0, 14, and 8. 14 and 8. Okay. Now what happens next is over here. Now over here also we will have a negative sign. We will get a 0 over here. If we multiply it with any values of the determinant, it will become 0. And this last one is also equal to 0 because of this 0. So therefore, if we multiply it with any values of the determinant, it will become equal to 0. There is no need to write them. If you won't write them, you're just wasting your time. Now what happens over here is next is that we will take 6, okay, as it is. We will solve through the first row operation. We will multiply it with 14. And then what will we do is that we will solve it. How will we solve it? Now we have taken 40. So therefore the first row and first column are eliminated. 16 multiplied by 8, which is equal to 128 minus 14 into 0, which is equal to 0. Okay, now I'm solving it for this particular determinant only. Then what happens is that we will have again minus 6 because this 6 will be multiplied with all the elements of the first row. Then we will get the 8 over here, and then if we have taken 8, then we will eliminate first row and second column. We will multiply 6 with 8, that is 6 multiplied by 8 is 48 minus 0 into 1. Again, there's cross multiplication. 6 multiplied by 8 minus 0 into 1. So therefore 0 ones are 0. Okay, the next value is 6 into 0. And if we multiply this value with any values in this determinant, it will become equal to 0. So therefore, there is no need to write it. Then we have the 16 over here. Okay. Okay, let's do one more thing over here. Write this whole into a big bracket. So now we have another 16 over here. Therefore, minus 16 into 1. This 1 comes from here. Now, first row, first column are eliminated. What we get over here is that 16 multiplied by 8. And the value of 16 multiplied by 8 will be equal to, okay, let me solve it. 16 multiplied by 8 is equal to 128. Okay. And put a big bracket over here as well. Then what next we have is minus. Again, we will write 16 and we will multiply this 8 with it. Clear? And then we will assign a bracket small over here. Now 16 multiplied by 8, it means that we have taken the first row, second column. 0 multiplied by 8 is 0. 0 multiplied by 0 is equal to 0. So therefore a 0 will come over here. Then we have 16 multiply by 0. If we multiply 16 with 0, we get a 0. No matter whatever multiplication we further do, if we multiply with those with any values of determinant, they will automatically become equal to 0. So therefore, after solving this, we get 6 multiplied by 14 is, I think, 84. Okay, 6 multiplied by 14 is equal to 84. Okay, multiply by 128. Okay, minus 6 into 8 is 48. Into 48, all the remaining values will be equal to 0. So therefore, there is no need to solve them. Okay. By solving this, we get 10752 minus 2304. Okay, wait. Okay. By solving this, we get 1052 minus 2304. Okay. And we will also insert this value into this, where that is, we will get minus 2048. So therefore, 84 into 128 minus 48 into 48 minus 16 into 128. We have substituted these values over here, and the final answer with us is 6400. 6400, which is also greater than 0. If the values of all the determinants are greater than 0, then we say that the time path is convergent. Because, okay, let me go back. Now the first determinant, that is A1, is greater than 0. You can see that it is greater than 0. It is a positive number. Then the 2 cross 2 matrix determinant is also greater than 0. That is, it is equal to 68. Then our third determinant is also greater than 0. And in the end, our fourth determinant is also greater than 0. Therefore, all the determinants are greater than 0. We will simply say that the time path is convergent. For all the determinants greater than 0, time path is greater than, time path is convergent. If in any case we are solving a question, okay, similar example, where what happens is that some of our determinants are positive and some of our determinants are negative, or even all the determinants are positive and there's only one determinant that is negative, then we will say that the time path is divergent. So therefore, when all the determinants are positive, time path is convergent. When one or more than one the determinants are negative and the remaining are positive, then we say that the time path is divergent. Now suppose we have another question, that is y cubed t. Okay. Now we have to solve for this question, minus 2y squared t. Okay, this is another question. This is, let's say this is question number 2. This time path is convergent for our previous question. Okay, y cubed t minus 2y squared t minus y prime of t plus 2y is equal to 4. Plus 2y is equal to 4. Okay. Now over here we know that the highest order derivative is y cubed t, therefore the value of a naught is equal to 1. Now the value of a1 is equal to minus 2. The value of a2 is equal to minus 1. Okay. And the value of a3 is equal to 2. So we will start finding out the derivatives. Sorry, we will start finding out the determinants. The first is 1 cross 1 determinant, that is A1. A1 is equal to -2, therefore it is less than 0, which is a negative number. Then what we do is that our next step is to find out the 2 cross 2 determinant. In 2 cross 2 determinant, we will have A1, A3, okay, A0, and A2. Okay, so what we get is simply substitute the values into it. A1 is -2, A3 is 2, A0 is equal to 1, and A2 is equal to -1. So therefore, the determinant will be -2 multiplied by -1 is equal to +2. -2 into 1 is equal to 2. Therefore, 2 minus 2 is equal to 0. Over here, the determinant is neither greater than 0 nor less than 0. Rather, it is equal to 0. Then, what we do is that we will find out the 3 cross 3 determinant. For that, we will have A1. Now, this should be clear for all of us. Now, this is A1, A3, A5, okay. The next one is A0, A2, A4, and then we have 0, A1, A3, 0, A1, A3. So by solving this determinant, we get, first of all, let's substitute the values. Okay, we get -2, 2, 0, -2, 2, and then we have a 0, 1, -1, 0, 1, -1, and 0, and the last row is 0, -2, 2, 0, -2, and 2. We very well know how to solve for 3 cross 3 matrix. What we'll get over here is -2. Okay, if we take this -2, we will eliminate the first row, first column. We will multiply -1 with 2, we get -2, and 0 with -2, we get a 0. Okay, then we have -2. Okay, and then first row, second column is eliminated. We get 1 multiplied by 2 is 2, and 0 multiplied by 0 is 0. Then the last one is plus 0. If you multiply 0 with any value, it will become equal to 0. -2 multiplied by -2 is +4. -2 multiplied by +2 is -2. Therefore, 4 minus 2 is equal to 2, and the value is greater than 0. So one value of determinant is greater than 0, the other determinant is equal to 0, and another determinant is less than 0. So therefore, when we encounter such kind of situation, we say that all determinants are not positive. Therefore, the time path is divergent. Okay. Now, in this case, the time path is divergent. Okay. Time path is divergent. Is divergent. That is, it is diverging from a particular point. Most probably that particular point is referred to as an equilibrium point. So time path is divergent in this particular case. This topic has finished over here. After this, we will move on towards our new chapter, which is the first order difference equations. So therefore, differential equations have finished at this particular point. Now, after this, we will move towards the difference equations, and I will see you in those lectures then. If you have any questions regarding any kind of differential equations, you can ask me. Thank you very much. Okay. Bye-bye for now.